This is chapter number 4. In this chapter, I want to talk about the Newton's laws. It's related to motion. And I want to talk about the motion analysis of particles here. Therefore, this is the subject of this chapter. Newton's laws. Before definitions and before Newton's laws, I want to talk about the force quantity. And I want to talk about the effect of forces. What is force? Force is a kind of quantity which causes translation and it causes motion for the particles. Consequently, here, if you have an object imagine it's on the flat surface, like this figure. You need a quantity to move this object from first place to second place. Therefore, what do I need to move or to excite this object here? That's force, this quantity called force. So sometimes force causes motion. Sometimes for maybe a stationary object, maybe force doesn't cause motion, but at that moment it causes deformation for your object. I'll explain. But right now, imagine we have motion from the force. So here, force in physics should be shown like an arrow. This, look at the red color here, it is force, F. Therefore, for every analysis in physics theory, you have to show your force as an arrow. And it has direction. It has magnitude and direction. Consequently, force is a vector. Okay. Therefore, force is a kind of quantity which causes motion or either motion or deformation. Okay, look at this figure. If I apply this force on this particle, it will move and it will go to the right. Because of this motion, you can have movement for this particle. Therefore, this quantity causes translation or it causes movement for this particle. For any other objects, you can have this condition. And you can generate translation because of the force. So here, look at this quantity, I mean force. As I told you before, it has magnitude and it has direction. For example, to the right, like this figure, or maybe it's to the left, maybe it is up, maybe it is down. It should be given. Therefore, you need two items to show this quantity completely. The first one is magnitude and the second one is direction. Therefore, it is a vector. This is next example of vector. And that's very important. Force is a kind of vector. The unit of force is Newton, the name of this person. I mean, Newton was a physicist, and he focused on force and force effects. Therefore, the unit of force is Newton. Like this. For example, 100 newtons, 5,000 newtons. This is the magnitude. And you need direction as well. For example, it's to the right, or it's to the left, or upper right, or lower left. You should know. You should know both of them. Okay. For example, here, I want to move a desk on a flat surface. What do I need to move the desk? Of course, I need force. And you have to apply this force along your specific direction. At that moment, you can move it. Sometimes, as I told you before, for example, you have a huge, very huge object, or you have a stationary object. Imagine here. Imagine you have a stationary object here. Like this. Should you here? This one is better. And that's fixed. It's completely fixed. Like a wall. That's, imagine it's a fixed wall. Okay, if you apply a force here, so what do you think? Of course, you cannot move it. This is your force as an arrow. You cannot move it because it's completely fixed. But what happens here? If you magnify this location, maybe by microscope, at that moment you can observe over here, you can have a deformation for your location. Similar to this. Like this. Like this. This is deformation. Imagine this is your object here. Prefer to move it outside the figure. Sorry. This deformation maybe is almost large. Maybe this deformation is so small. It depends on the elasticity of your object. It depends. But you do have deformation because of the force. In other words, you can have either motion or deformation. If you cannot move your object, definitely you will have a deformation. And if your object is completely free to move, you can excite it by your force and you can move it. This is definition of the force. Okay, that's good. Now we can switch to Newton's laws. Actually, Newton was a physicist and he focused on many important problems in physics, and he discovered many laws, and they're so important in physics, and we need these laws frequently in physics theory. This kind of physics, which is based on Newton's laws, and actually Newton's discovered some other laws except laws of motion, but all of the laws of Newton, and they were discovered by this person, they're so important. If physics, which is based on Newton's laws of motion and Newton's law of gravitation, I'll talk about it later. It is called classical physics. Right now, I want to talk about the Newton's laws. There are three laws for motion, and I want to explain all of them. And you have to memorize each law because that's a test question. Okay, law number one. It is called Newton's first law. Imagine there is an object here. I want to talk about it in simple words. This is the flat surface. And imagine there's a block here. If you have many forces, let me put it like this, if there are no forces on this object, or net force is zero. What is net force? I mean, combination of all of forces on this object, but the final result is zero. I mean, they will cancel each other. Like what? Like this one. For example, you have 200 newtons of force to the right on this block, and you have the same force, 200 newtons to the left applied on this block. The same force, 200, but opposite direction. I mean, the first one is to the right and the second one is to the left. Therefore, they will cancel each other. It means you have zero net force. Over here, you can call it net force is zero for this condition. Okay, let me repeat it. If there are no forces on your object, or net force is zero, like this figure, that object has either equilibrium or constant velocity. This is the definition of first law. It is called Newton's first law. Therefore, here, if there are no forces on an object, or there is a zero net force. Net force. Like this figure. Net force. On this body. This object has either equilibrium or constant velocity. And it depends on the previous situation. If, for example, there is no motion for your object, and now if the new condition, there are no forces on your block, or net force is zero, this object should have equilibrium. And imagine the previous condition of this block. It has velocity. And new condition, if there is no force or net force is zero on this block, it has constant velocity from this position, and it has always this constant velocity. This is Newton's first law. Thank you.